Hello everyone and welcome back to another video, and today we will be working question 7 from the January 2021 math paper 2. If you're hearing any noise in my background, Elsa has now arrived where I am. That's Tropical Storm Elsa. So that is the noise, but the show must go on. So question 7 says the diagrams below show a sequence of figures made up of circles with dots. Each figure has one dot at the center and 4 dots on the circumference of each circle. The radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle. Except for the first figure, a portion of each of the figures is shaded. So part A says complete the rows in the table below for figure 5 and figure N. So what we're looking at is for the number of dots formula. So this is the second column here. First, what I always encourage students to do is to find the formula, because after finding the formula, then you can test to see if it is correct and you can easily figure out for each missing number or variable that they ask you to find. So what we realize is that from the number of dots, the second column, there's always an increase by 4. So from 5 to 9, there was an increase by 4. From 9 to 13, there was an increase by 4. And 13 to 17, there was an increase by 4. So what we know is that we can then go ahead and multiply n, which is the figure number, by 4. So 4 multiplied by n will give us 4n. We can now test this and see if it will give us the number of dots in column 2. If not, we know that we need to perform another operation, which is either addition or subtraction of a number. So in now testing the formula, 4 times n, which is 4 times 1, would give us 4. 4 times 2, which is figure 2, would give us 8. And 4 times 3, which is figure 3, would give us 12. What we realize is that in each instance that we just worked out, the number of dots is always short by 1. So therefore, we can then conclude that if we add 1 to the current formula, then we will always get the number of dots that is needed. So for example, if we did 4 times 1 plus 1, we'll get 5, which is corresponding to the number of dots in figure 1. If we add 1 to 8, we'll get 9, which corresponds to the number of dots in figure 2. And if we add 1 to 12, we get 13, which corresponds to the number of dots in figure 3. So now with testing figure 4, since that we now know that is always short by 1, we can then rewrite the formula to be 4n plus 1. So now testing figure 4, it is 4 multiplied by 4, which is 16, plus 1, which gives us 17, which corresponds, according to the table, to figure 4, the number of dots. So now we can go ahead and find part 1 under the number of dots. So then n in our formula from 4n plus 1 would be 5. So what we have is 4 multiplied by 5, which is 20, plus 1 will give us 21. So therefore, our answer for the number of dots is 21 in figure 5. And we can go ahead and solve what n is. Well, not really solve, because we already solved that, which is, and as you remember, every time we see n, what it is asking us for is a general formula for this particular column. We already solved that before, so we'll just go ahead and input that into our table, which is 4n plus 1. So no matter which figure number you have, once you use the formula 4n plus 1, you will always get the formula. I'm now going to jump to column 4, which is the area of shaded region. There's a D missing, so that should be area of the shaded region. So what we know is that it is always increasing by 2 pi. So first we had 1 pi, then it went to 3 pi, so there was an increase of 2. Then it went to 5 pi, which was an increase of 2. Then it went to 7, which is an increase of 2. So therefore, what we can say is that our formula then is 2 pi multiplied by n, which gives us 2 pi n. So if we test it, and we do 2 pi multiplied by n, our first n was 1, we get 2 pi So we realize that there's a difference of 1. Then we go 2 pi multiplied by 2, we get 4 pi. So again, there's a difference of 1. So our formula is always showing that we are basically, we're accounting for an additional pi. So it is always over. And then we have 2 pi multiplied by 3, and we get 6 pi, which is over by additional pi again, as the answer should be 5 pi. So we're always over by 1 pi. So therefore, what we can say is that therefore our formula is 2 pi n, which is what we currently have, subtract by 1 pi, which is what it is always over by. From looking at this formula, we realize that we can factorize it or simplify it a bit more, because what is common to both terms is pi. So we can remove pi from both terms. It is our common factor. It goes on the outside. Then we say pi into 2 pi n will leave us with 2n, and pi into 1 pi will leave us with 1. So therefore, the general formula that we're therefore using is pi multiplied by 2n minus 1. And we're now going to test this on our figure 4. So our figure 4, we're going to replace n with 4. So we have 2 multiplied by n, which is 2 multiplied by 4, to give us 8. So it is 8 minus 1 to give us 7. And therefore what we have is pi multiplied by 7, which is 7 pi. And that corresponds with our figure 4 element there. So therefore we can now work out part 1 for column 4 here, which is corresponding to figure number 5. So what we have is pi multiplied by 2 multiplied by n, which is from our formula 2n, so 2 multiplied by 5 minus 1. 2 multiplied by 5 is 10, minus 1 is 9. So what we'll have is pi multiplied by 9, which is the same as 9 pi. So our answer for figure 5 is 9 pi, and n, which is our general formula, is pi multiplied by 2n minus 1 in bracket. So these are the 4 answers that we figured out so far. So we've already got what, 4 out of the 7 marks. So we have 3 marks left to go. So now we're looking now at the area of the outer circle, which is the largest circle. There is now not a set increase like a set figure, so we cannot multiply a particular number by n. But from what we realize is that all these numbers are actually squared numbers. So we have a 1 square to give us 1, a 2 square to give us 4 pi, a 3 square to give us 9 pi, a 4 square to give us 16 pi. So what we realize is that the figure number is squared in each instance to give us the area of the outer circle. So let me say that again. The figure number is squared in each instance to give us the area of the outer circle. So when the figure number it is squared, then it is multiplied by pi, and that gives us the area of the outer circle. So therefore, our general formula is n squared multiplied by pi, but we're going to test it first to see that if our theory stands true. So 1 squared multiplied by pi, 1 squared is 1 multiplied by pi will give us 1 pi or pi. 2 squared multiplied by pi, 2 squared is 4 multiplied by pi will give us 4 squared. And 3 squared multiplied by pi, 3 squared is 9, 9 multiplied by pi will give us 9 squared. So n, therefore, for this column, our general formula is n squared multiplied by pi. And that is our 5th mark. So we have 2 more marks to go. So now looking at our last column, which is the total length of the circumferences of all circles, what we realize is that if we add n multiplied by pi to the 3rd column, which was the area of the largest circle. So if we have the area here, let's say look at figure 2, we have 4 pi, and if we add plus n multiplied by pi, n again is 2, so it is 2 pi to this. So 2 pi to 4 pi will give us 6 pi. For figure 1, it would have been the same. Pi plus n pi, it will be 1 multiplied by pi. So pi plus pi would give us 2 pi. So therefore, what we realize then is that our formula can mimic something like n squared pi, which is the general formula for the third column, the area of the outer circle, plus n pi. We can then factorize this as what we realize is that n pi is common to both terms. So therefore, n pi into n squared pi will leave us with n, and n pi into n pi will leave us with 1. So n pi into n squared pi will leave us with n. The n cancels out one of the n here, will leave us with 1 n, and pi cancels pi. So we have only n here, and n pi into n pi leaves us with 1. So we're using our general formula to be n pi multiplied by n plus 1. So we're testing on figure 4, where n is equal to 4. So what we have is 4 pi, so 4 replacing the n here, so 4 pi, then in bracket 4 plus 1. So 4 plus 1 is 5, and then what we have is 4 pi multiplied by 5, and that will give us 20 pi. And therefore we know that our formula stands true. So therefore, testing it now for part 1 in figure 5 for the total length of circumference of all circles, what we'll have is 5 multiplied by pi, so 5 replace n in each instance, and then in bracket 5 plus 1. So 5 plus 1 is 6, so what we'll have is 5 pi multiplied by 6, and therefore that will give us 30 pi. So our answer right there will be 30 pi, and we already generated our general formula, which was n pi, and then multiplied by in bracket n plus 1, and we just got our full 7 marks. Now part B says, determine the value of n when the number of dots in figure n is 541. So we have our general formula for the number of dots, which is 4n plus 1. So therefore, 541, which is the total number of dots, is equal to 4n plus 1, and we're going to solve for n in this instance. So we're going to subtract 1 from both sides of the equation. So what we'll have is 541 minus 1 is equal to 4n. So therefore, what we'll have is 540 is equal to 4n. We can now go ahead and solve for n. The 4 was multiplying here with the n. So what we'll do is divide both sides of the equation by 4. And what we'll have is 540 divided by 4 is equal to n. And when you put that in your calculator, you'll get n to be 135. We can even go ahead and test if this is true by putting 135 for the value of n into our formula. So what we'll have is 4 multiplied by 135 to give us 540 plus 1 to give us 541, and that is how we know that our answer for part B is indeed correct. So n is equal to 135. Part C now says, write down in terms of p and pi the area of the largest circle in figure 3p. So now it's no longer just figure 3, but it's now figure 3p. So we're calling it figure 3p. So for example, we have figure 1p, figure 2p, figure 3p, and figure 4p. So the area of the largest circle, the formula that we have for that, which is column 3, was n squared multiplied by pi, or n squared pi, where n was equal to the figure number. Now our figure number is 3p, so therefore n is equal to 3p, and this 3p is what we're going to put into our formula, replace n with. So therefore n is equal to 3p, so what we'll have is 3p squared multiplied by pi. And 3 squared is 9, and p squared will give us p squared multiplied by p, and therefore our answer is 9p squared, and that is the area of the largest circle in figure 3p. And this is the end of question 7, and we thank you so much for tuning in with us, and we'll see you for question 8.